In this Excel tutorial part 4, we will use the standard curve that we constructed in the previous tutorial and use that information to calculate the concentration of an unknown. In the previous tutorials, we constructed a spreadsheet, performed calculations and a linear regression using the LINEST function, and also plotted a graph. Now suppose, having constructed a graph of protein standards, we are now given an unknown solution. We go into the lab and we measure the percent transmittance of our unknown solution at 280 nanometers, and we discovered that its transmittance is 280 nanometers. Our next task is to determine its protein concentration. First, though, we will have to convert percent transmittance to absorbance, so we will need our formula to do that. Here, our formula, remember, is 2 minus the log of the percent transmittance. So I can just take this formula that I've written here and copy it for my unknown. Remember here, this C11 is a relative address, so when an Excel copies it, it copies it to this particular solution right here. In order to calculate the unknown concentration, now that I have its absorbance, I'm going to use my LINEST data. The equation of a straight line is y equals mx plus b. In our graph, our y values are absorbance values, and the x values are concentration values, which I've abbreviated as C. So I've rewritten the equation of my line. Now I know the absorbance, and I know the slope and the y-intercept of my standard curve, so I just rearrange this equation to solve for C. So in order to solve for C, the concentration, I just take the absorbance, subtract from that the y-intercept, and divide by the slope. I've returned to my spreadsheet and I've highlighted cell B13, and I'm going to write a formula to determine my unknown solution concentration. So again, using the equation I just showed you, equals, I'm going to use some parentheses here, its absorbance is in this cell right here, in B13. I subtract from that the y-intercept that was down here with our LINEST data, close parentheses, and then divided by the slope. And then I click on enter, and that is the concentration of my unknown solution in micrograms per microliter. I'm going to adjust the significant figures so it matches those of my standards. So my unknown solution concentration is 0.236 micrograms per microliter of water. And I determined this by measuring the unknown solution's transmittance, converting it to absorbance, and using the LINEST data, which is shown visually by my chart right here. We can check ourselves by looking at the graph to be sure we've done this right. The unknown solution's absorbance was 0.33. If I look on my graph, 0.33 is about here. So if I draw a line over and drop a line down, I get a value that's a little bit above 0.2 micrograms per microliter. And that is what I calculated, is 0.236 micrograms per microliter. So that's a nice check to make sure that the formula was entered correctly. So in conclusion, we have taken data in Excel and we've performed some calculations. We have used the LINEST function to perform a linear regression calculation. We've illustrated that by plotting a graph, and we use the information from the slope and the y-intercept in order to determine the protein concentration of an unknown.